I'm speaking with Gagan Agarwal, who's the co-founder and CEO at Planet Electric. And Planet Electric has recently showcased its first prototype of electric LCV. So we're going to talk about that. We're going to understand what is it that they are particularly innovating on and what is their go-to-market. Electric LCV space has been seeing some traction of late. We have Tata Ace, Jupiter, and then Switch Mobility launched electric LCVs. And then we have new age vehicles like startups like EVH putting out their vehicles on the road. So what is it exactly that you are innovating on?
The first big gap that we saw in vehicle manufacturing is the weight problem. So the structure that defines the vehicle has been traditionally made out of sheet metal. And this hasn't really changed in the last 70 odd years. But Tesla, I think, was one of the first to go to a die pressurized casting for aluminum, that is giga casting. And that's where they were able to shave off a lot of weight, shave off a lot of weld requirements as well. That approach is still expensive for India. So when we approached this problem, we looked at, can we bring affordable composites, not very dissimilar to the ones in aerospace or aviation that we use, and build a superior technological and business case out of it. What I mean per se is, can these materials give us the same amount of strength, durability, crash safety, the manufacturing speed, as well as repairability as sheet metal, yet lightweight enough so that we reduce on the battery consumption and provide much superior cost economics for our users?
You claim of achieving up to 70% lightweight structure that is also durable for like up to 15 years and ends up reducing required battery capacity by up to 50%. So these are actually big claims, big numbers that you're speaking about. So I want to understand what kind of validation have you received for these claims that you're making, and how can an OEM or a fleet operator be sure of these metrics?
So two or three things, right? We are not traditional OEMs. We are not design first, or we don't build clay models and then build. That's not something where we come from. We look at the functionality of the vehicle. What is the speed, acceleration, payload capacity, gradability, these kind of metrics. We go back and design a structure. We look at how each part can be manufactured affordably in composites. We simulate that structure for 4G static load conditions, durability, crash safety simulations. And we convince ourselves that with enough margin available, this vehicle can run on road. So everything is pre-flight, just like you do pre-rocket flight. You want to be doubly sure. And then you put the vehicle on road. So these are the metrics that we have proven within simulations. The next proof of the pudding comes when we start giving these vehicles to our customers. We have about 2,600 pre-orders, and the customers that will take these vehicles will be able to check the spec, whether are they receiving the right payload, on-road range, gradability, battery health, and other parameters.
Understood. So can you quickly walk us through the main specifications in terms of range, battery, top speed, etc.?
Absolutely. The first vehicle we're putting out is a 750 kg rated payload. And this will have 185 kilometer certification range. That range will be able to give you very comfortably around 130 to 140 kilometer on-road range. This will be 23% gradability rated, as well as we are putting in our own algorithms, supervisory control, so that we are able to achieve a battery warranty of 250,000 kilometers as opposed to 175,000 that some of our competitors are offering in the market.
Right. And what is the size of the battery pack for this?
This would be 15 kilowatt hour.
While you were developing this product, you were researching, you must have spoken to a lot of potential customers, let's say fleet operators and all. So because there are already some vehicles on the road, catering to electric vehicles, catering to LCV requirements. So what kind of feedback did you receive from them that you acted upon to make sure that you resolve those particular issues for your customers?
Absolutely. There were 4 or 5 issues to resolve here.
Mhm.
Number one is the payload problem. As soon as you've taken up a chassis and a body of an existing diesel CNG vehicle and you put heavy batteries on top, immediately what you see is your payload going down for that same range that you want to get. And that is the biggest issue today because that means your revenues are actually going down. Secondly, volumetric loading has been a big issue. EVs are very promising for e-commerce vehicles. They apply well to courier kind of applications a lot within the last mile delivery today. And the packages now have a tendency to become more and more lighter. They have more volume, less weight as compared to the earlier packages. That means you need more volumetric loading capacity. So more than the standard 200 cubic feet that vehicles in this category bring. Number three, many operators have tried to have a three-wheeler scale up, but that also has not been possible because of gradability issues. You cannot go over high slopes, over bridges, underground issues, helper problem that typically comes in this segment, as well as engineering issues, fundamental engineering issues in being able to scale up that three-wheeler to higher load capacities. So here, if there is an operator who wants to do 750 kg to 1000 kg, has about 90 to 100 kilometers everyday range, wants this vehicle to last about 7-8 years, which means the battery should last. The gradability should be 23% or more. All of these features are not available, and no engineering can get you those features if you want it economically. Otherwise, the battery pack size would go to 35 kilowatt hour, right? These are contradicting features. And it's only possible when you start ground up. You don't lightweight a fender or a seat or a door. You lightweight the chassis itself and the body. Then you've really achieved almost, and we've at the end, when we come out with the production vehicle, we would have achieved more than 500 kgs of lightweighting on the vehicle level.
And what is the price point, target price point for you when you bring this vehicle out?
So we've published that on our website, and we're very much looking at 10.5 lakhs as the price point. We are also able to give some discounts with customers who have placed their pre-orders with us. And we want to keep it that way because we do have efficiencies in our BOM. We haven't gone out of our way and modified everything. We have built a new structure and we control the software, but the entirety of mechanical, electronic, and electrical parts are outsourced from the vendors who have the highest economies of scale. So transfer pricing applies, and we don't take a hit on our BOM as a new age OEM.
Talking about fleet operators and their experience with electric LCVs and so on. So are people actually saving money using electric commercial
No,
vehicles?
not right now. No, not right now.
Always when we talk about electric vehicles, we talk about, hey, okay, the starting price is a lot higher, but over a period of 5 years, you'll end up saving money. So can you give us some sense of what is happening right now?
What is happening is a CNG or a diesel vehicle would have given you an EMI of about 30,000 rupees per month. An EV built on the similar platform gives you about 23,000. So you are already 10,000 rupees less. On top of that, the difference in the diesel or CNG versus electricity is about 4,000, 5,000 rupees today. Even less sometimes. When you actually start to fast charge, that difference comes down to about 3,000, 4,000 rupees per month. So you already are in a debt, right? I mean, and the typical profit margins in this business is 5,000 rupees or 4,000 rupees. So basically, you're not making any money, which means every single fleet operator has to compulsorily run 2 shifts. The problem in running 2 shifts, I mean, the pro in running 2 shifts is you're splitting your EMI between 2 shifts. Great. But the problem is, one, there is not enough certain business available in 2 shifts. For 1 shift, for sure. Um, Second is the fundamentally you have loaded up higher. So in a CNG vehicle, the AMI is less. You can run and expend on the fuel. So it's easier because you don't have an upfront burden. Here you have an upfront burden and you must make business, otherwise you're doomed from the start. And that has been the problem of many fleet operators as they have conveyed to us. And this is where we have to lower both EMI as well as the charging cost to eke out some profit on the first shift itself. The vehicle should not go into the second shift to earn a profit. Number two, you have to give enough volumetric loading so that they have the potential to earn about 5,000, 6,000 rupees extra revenue. And with that, you can show better profitability than a CNG vehicle in this vehicle itself.
Right. So I also want to talk about retrofits here. Like we know that KPLT is working on electric, they are retrofitting old LCVs into electric. And there are many other startups who have attempted this with limited success. So I want to get your opinion on it. Do you think it's a long-term sustainable approach to electrification? And what do you think of these vehicles which are built totally on ICE structure, ICE body, and then we are just replacing some parts with battery?
Right. So, I mean, if you compare an OEM and a retrofit player, the OEM is also doing very similar, but all in-house. So they are taking an existing chassis and they're putting all the components on top, which is an electric powertrain with a battery and a software, and shipping that out. Now, what a retrofitment guy would do is also the same. However, if they are buying off the shelf, then they would have to remove the engine and other things. That seems to me like a waste of money, because that means you're always going to be 1.5 lakh rupees higher, about $1,500 at least higher than what comes out of an OEM. But if you're able to source the chassis itself and then retrofit, sure, I think there is still some 4 or 5% market for that, which is the starting market, the early adopters, who are paid to run on an EV, right? Because certain brands want to have electric transportation. But no, look, wherever any industry has gone for a retrofit, I think fundamental efficiencies have never been there. So it is a starting option, but I think long term, whoever is doing it, they will also have to consider being a proper OEM to be able to eke out the margins they want.
Right. Understood. So we'll come back to your innovation that lies in materials and structural engineering. And can you give us a little more about what these materials are and why is it that others are not using it?
Well, industries get built around vendor basis. If I mean, sheet metal has a really long history, more than 7 decades. So if every single of your supplier within casting, stamping, and then you have in-house welding, paint shop, you've set that process. And hundreds and thousands of cars out of say a Suzuki or a Tata or a Mahindra are coming out. You're not ever going to overnightly change your process. You are going to, however, see what is the possibility to lightweight, which we have seen. People have lightweighted their fenders, their seats, their doors, bonnets. There has been piecemeal approach to it, but that is all it can be. And that doesn't give you any lightweighting. It gives you 2%, 5% lightweighting, nothing more than that. If you really want to go, you have to go ground up. Composite materials are very different from sheet metal. They are not isotropic, which means they do not possess the same strength in all three directions. They're different strength because these are fiber with, impregnated with a resin system, which fundamentally means engineers need to design them very differently than sheet metal designers. Simulations are also very different. Tests are very different. This knowledge, number two, doesn't exist within OEMs today. It is easy for large OEMs to get this knowledge for sure. But then the third concern that they are faced with is we'll definitely have to put a new capex to build this. And then will their board allow to cannibalize their existing capex or not is a question they have to answer. I think in all of this, we've seen experiments happening since 1990s in the US at least. A piecemeal approach in the Europe. India still very new. India, I think, in the last 5 or 6 years has still been reeling on the BS6 capex upgrades. So I mean, it's too harsh to ask of them to even look at this. But again, this requirement really came through when we switched to EVs, or as the industry is going. In a diesel vehicle, you don't care. You put a sheet metal, the vehicle runs, and it gives you some economies that you're accepting it, right? You people accept 80, 90 rupees per liter price, and they're able to make money out of it. In today's market, they're not able to do it with EVs, or they won't be able to do it with hydrogen. And that's where innovation in structures now becomes important, not 5 years before.
All right. And what, like, if you talk about your first vehicle, what is the curb weight of the vehicle that you come up with?
Yeah, so the target curb weight that we'll be giving to our customers is about 700, 750 kgs. That's the target for the specs that I told you.
Okay. And if we compare with, let's say, a Tata Ace, what would be the curb weight of that vehicle?
I think Tata Ace EV has about 1250, if I'm not wrong, 1240, 1250,
Around that range. Okay.
around that range.
Okay. Understood. And so being an OEM, of course, is a very capital intensive business, and being a startup. And we have seen instances where people innovate, they come up with a prototype, but then they have a lot of challenges actually commercializing that, going
Yeah.
into business, and it has to be a long marathon. So
Yeah.
what is your plan? How are you going to approach it in terms of building the capabilities for manufacturing, or raising money, where you are at? Just walk us through your go-to market, what you're planning.
Absolutely. So we raised a small pre-seed last year that allowed us to come to the prototype stage. We are closing a convertible round right now in the next week or so, and then we'll be going for a much larger price round that will allow us to complete our customer testing, complete certifications, have enough supplier capex for the dies and molds that we want to develop for composite structures, keep the supply chain ready. And then simultaneously, we're also talking, shortlisting on how we can approach contractual manufacturing to reduce the capex burden on us from a plant point of view, and then sort of merge all of it around the March end 2025 timeline to be able to go to a start of production. So we have a very tough 9 months ahead of us. I would say deadlines would be very, very crucial for us to deliver. But one thing that we know is certain is our customers need this vehicle, and they have given it to us in writing. And that there is no other vehicle that can compete with us on these specs and this price in the market, not just in India, anywhere. Even if we take this vehicle, refurbish it with, let's say, Middle East, refurbish it with GCC AC guidelines and with the aesthetics that are required in that market, we still would not have a competitor anywhere close. So these are the fundamental efficiencies we have. To your earlier point about an OEM, it's an unfortunate fact that we have to be an OEM. I think it would be much easier for us to be able to license this out, have a contractual supplier, and then give it to large OEMs. This is something that we've not been able to achieve thus far. And there are issues in that because a battery, right? You can like for like replace a battery pack. You need electrical connection, a CAN connection for data. You need mechanical mounts. You need coolant connection, pretty much. But a structure itself has 80 to 90 mountings, and the IP is in every single of those mountings. How do you do that? So this is durable across the lifetime of the vehicle. How do you repair that if something breaks? This is something that poses a challenge to us in being a tier one supplier or a licensing company. But we hope to get there sometime in the future. The first go to market is, of course, being able to sell the vehicles.
Okay. So right now there is one vehicle available for fleet operators and
Yeah.
other to test.
This is the first prototype that we
Yeah.
have put out. We'll put 5 more by September, and we'll go for customer testing.
All right. So pleasure speaking with you, Gagan. I can see you are a young team who've done a lot of work behind the scenes before you were able to bring it out. So I really hope we get some disruptive products in India and that inspires the rest of the world. And I think I wish you guys the very best for doing that.